Please join me in giving a big South by Southwest welcome to Kate and Trevor.
Hello, Texas. How's it going? I'm Trevor. It's great to be here. I'm really happy to be here with Kate Crawford, an AI researcher who's a distinguished professor at NYU, where she co-founded the AI Now Institute, which is the first center dedicated to studying the social implications of AI.
And I am equally delighted to be standing here with Trevor Paglen, who is an artist, but he's also a lot of other things. He is also, I think, in many ways, a very deep researcher. And he has been recognized as a MacArthur Fellow. You won the Namjoon Pike, I think, like 2 months ago or something. And he's also the first AI Now Artist Fellow. So because of that, we've been doing some interesting collaborations that we're going to share with you today.
Yeah, so Kate and I have been collaborating for a number of years, but one of the big projects that we're working on right now is a major exhibition about artificial intelligence and images, and this will be opening at the Prada Foundation in Milan in September. And this project involves looking at hundreds of training sets and thousands or even actually millions of images. And this has turned into a really deep dive into the nature of the image within artificial intelligence systems. And so today what we're going to do is to show you some of the early findings of our research into that and some of the questions that we're trying to ask. We're trying to ask things like, what images are used to create AI systems? What work do those images do? And finally, what's at stake in how AI systems harvest, label, and use those images? And I have to start the talk a little bit with a little bit of a trigger warning, which is that a little bit further into the talk, we're going to be showing some pretty disturbing images from different AI training sets. And so just to warn you, in about 15 minutes or something like that, it might get a little bit gnarly, so if you don't want to deal with that, don't. And so to begin our story, I hand it over to you, Kate.
Thank you, Trevor. So this is actually going to be a bit of a mystery story, because a few weeks ago, around 1.2 million images of people vanished from the internet. And you know, maybe that's not particularly remarkable. I mean, things get deleted off the internet all the time. But this was a particularly significant set. This was actually one of the foundational training sets for artificial intelligence. It basically includes a vast archive of images, and they've all been labeled and assigned to categories. And it's basically used to train AI systems to see the world. And we were basically in the middle of this research project looking at the way that people are classified in this collection, when suddenly Trevor and I noticed, in fact, I got a call from Trevor, like in Berlin, and I'm in New York, and it's like the middle of the night over there, and he's like, Kate, all of the images are disappearing in front of my eyes. I'm like, what is going on? So you can imagine we were pretty freaked out by this whole experience. So I'm going to share with you some examples of what you can no longer see. So these images inside ImageNet were scraped from countless places on the web. Places like people's Flickr sites, from personal websites, from news sites, a whole range of different sources. And they were labeled into categories. Here are a few examples. The woman on the left is labeled a kleptomaniac. The man next to her is labeled a noticer, interesting. The woman next to him is labeled a mute, and Sigourney Weaver, randomly labeled as a hermaphrodite. I kid you not. So all of these images are part of ImageNet. It's essentially one of the sort of foundational training sets that really kicked off the latest wave of machine learning. ImageNet came out of a research project that was published in 2009, and it quickly became the gold standard for machine vision research, with basically labs around the world vying to see whose algorithms could most accurately label subsets of these images. It was called the ImageNet Visual Recognition Challenge, and it focused on pretty much the less controversial images, images of cats and dogs and fruit and stuff like that, which is why images of people have pretty much gone unnoticed and unremarked for the decade that these images have been freely available online. That was, of course, until last month when the 1.2 million people images suddenly went missing. So to understand the context of this strange collection, this strange disappearance, and why you should care about it, first we're going to have to back it up a bit. And we're going to explain to you how training sets work and how machine vision works. Over to Trevor.
Yeah. So if you want to teach a machine learning system or an AI system how to recognize different kinds of objects or identify different kinds of people, you have to train it. You have to train it to do that. So for example, if you want to build a neural network that can recognize the difference between an apple and an orange, you have to get a bunch of images of oranges together and a bunch of images to apple. You feed it into the system, and it develops a model with which to distinguish between the two. And these images that you use to train that model are called image data sets or training images. And that's the kind of thing that we're looking at here. If you want to build a very simple neural network, let's imagine building an AI system that can recognize things in your kitchen. The way that you first do it is you make a list of all the things that you want to be able to recognize, things that are in your kitchen: spoons, plate, banana, apple, fork, what have you. So the first thing that you do is you create a taxonomy, right? And then what you do is you have to get lots and lots of images of things that correspond to those categories, things that are in those categories. You feed it bunches of images of spoons, plates, forks, oranges, what have you. Then what the machine learning system does is breaks all of those images apart into what you can think of as, I think of as formal primitives or kind of building components. These would be things like edges, lines, ellipses, curves, gradients, colors, basic kind of shapes. It breaks all the images apart into these basic shapes. And then what you can do is once you've trained it, it'll look at an object and analyze the basic shapes that are in there and say, okay, look, an image like this might have some things like parallel lines, a couple of ellipses, maybe a couple of gradients from a silverish color to a gray. You put those all together, and statistically, that image is more likely to be a spoon than it is to be a refrigerator or an orange or whatever. So it's a very statistical way of analyzing images. You know, a fork is going to have a lot of the very similar formal primitives that a spoon will have, but it won't have an ellipse at the edge of the handle. Instead, it will have kind of a spiky thing. And a banana will, in turn, have very different formal primitives from either one of those two, right? Once you've done all of that work, you've created a system that recognizes these different objects. You can, if you've done everything right, you can give it an image that it hasn't seen before, and it will classify that image for you, saying this is a red and green apple.
So we're already completely surrounded by systems that are doing this in real time. This that you see right now is an example from a film that Trevor made, basically using off-the-shelf machine vision algorithms, open source, and then applying that to a string quartet. Now, of course, cameras like this are embedded in our urban infrastructures that are already photographing you as you walk down the street. They're photographing your car. Facial recognition systems are already installed in airports and at borders. And now, emotion detection systems are being used in shops to decide whether or not you're interested in a particular product. These same machine vision systems are also being used in hiring by companies like HireView that record your micro expressions as you're being interviewed for a job, and then they try to match your micro expressions to those of the highest performers in the company. You can imagine how that would generate a few instances of bias. And of course, now in New York State, insurance companies are permitted to track your social media to determine your lifestyle, whether you're healthy, whether you're unhealthy, and to use that to modulate your insurance rates. So there are obvious problems that can emerge in all of these systems, problems that can cause very serious kind of harm and discrimination. But today, we want to go a bit deeper than that rather than just talking about bias, we want to go into the very logic of seeing that is at work here. To do that, we have to look at some history. So what is the history of thinking that we can understand somebody's true identity, their character, or their limitations just by looking at their external appearance? I mean, if you think about it, that's actually quite a jump, that our interiority is expressed in our physical body. And there are, of course, some precursors here. We can go back to the 19th century phrenological experiments of people like Francis Galton. He was, as many of you know, a Victorian statistician who liked to make composite photographs of criminals, prostitutes, and people with mental illness. These experiments then became part of the foundation of what he would call eugenics. Around the same time, but across the Channel in France, Alphonse Bertillon was a French police officer and a biometrics researcher, and he invented what we now call the mugshot. And he used those images to track the facial characteristics of criminals in France. But you really have to go to Italy if you want to see how gnarly this can get. Cesare Lombroso basically believed that crime and criminal tendencies were inherited in your genes and that this could be seen in your face. He used ideas from physiognomy, psychiatry, and social Darwinism to claim that criminality was inherited and you could see it as a series of physical defects in someone's appearance. Of course, no scientific basis for this whatsoever. But if we fast forward to the earliest discoveries and uses of facial recognition, of facial detection for AI, we have to go back to 1963. This was when Woody Bledsoe was funded by the CIA to come up with the earliest systems to detect a face. This was actually computationally really difficult at the time. And we, of course, with much more processing power and many more images, have gotten much better at this. But actually, those ghosts of the past, those mugshots, still haunt AI. This that you're looking at now is a very well-used data set produced by NIST, the leading national body, called Special Database 32. And it shows photographs of people who have been arrested multiple times over the course of their life, so that, wait for it, you can, as an AI researcher, track the aging process. So essentially, by looking at criminals, it's used to just detect and guess how old somebody is. Now, there's a whole bunch of political and ethical questions you might want to ask here. I mean, just to begin with, there's the fact that criminals are regularly denied any type of privacy rights and are often exploited in this way. But as you're about to see, more and more people are about to be in that boat.
Now, every training set, like every system of categorization, has to have an overall taxonomy. In other words, what's the scope of concepts that you want to organize, and what is the architecture of that organization? So in our earlier hypothetical example, the taxonomy was things that are in your kitchen. But let's take a look at some real-life examples of this. So one area where there's a lot of work being done is in what's sometimes called affective computing. And these are systems that are trying to sense what kind of mood you're in, what kind of things you like or what you don't like, whether you're telling the truth or whether you're lying. And this is often done just simply by looking at your face. And the image we're seeing here is an excerpt from an early example of this sort of thing. It's from 1998, and it's from a data set called JAFFE, which stands for Japanese Female Facial Expressions. The database contains 213 images that are organized into 7 facial expressions. These are 6 basic facial expressions plus 1 neutral. So the taxonomy here would be something like emotions and facial expressions. This is a very similar data set from the same year called Karolinska-directed emotional faces, KDEF, also from 1998. Consists of 70 people, each displaying those same sets of emotions on their faces. Now, these emotional training sets are actually fairly representative of what goes on in this space. But we can see at that level of the taxonomy itself, we can see that there are assumptions that are built into the taxonomy. There's a kind of politics to it even. The first assumption would be that emotions makes sense as a taxonomy itself, that it makes sense as a concept that covers a bunch of categories of things. There's also an assumption that, that there are 6 emotions and that those emotions are somehow expressed on people's face in a more or less uncomplicated way. Now, where do these assumptions come from? Well, underlying this taxonomy of affects is the work of a psychologist, a guy named Paul Ekman. And this is something that Kate has spent a lot of time working on, that you've published some work around also with the AI Now Institute. So Ekman's work describes, he changes a lot over time. The basic premise of it is that there's a limited set of emotions. Those emotions are universal, and those emotions are visible by looking at the expressions of people's faces. Now, this is not research that has gone uncontested. In fact, it's been highly critiqued within fields like anthropology, psychology, and it's been repeatedly found to not really hold up to sustained scrutiny. But nonetheless, this paradigm has been widely adopted by AI researchers. And why is that? Well, on one hand, his paradigm is really quite perfect for AI because it assumes, again, that transparent relationship between appearance and essence, or a kind of exteriority and interiority. And it also assumes these kind of universal categorizations. And these are all easily turned into quantitative metrics. It makes it kind of work well for AI. But if you just think about those assumptions, for example, I have to go to dinner and lunch all the time with people, and sometimes I don't particularly like them, but I'm usually smiling. But that doesn't mean that I'm happy or that I like them or something like that. So it's very kind of easy just from a commonsensical perspective to start picking apart some of this stuff. This is a detail from an artwork I made that's called machine-readable Hito, which is made out of hundreds of portraits of my friend, the artist Hito Styrel. And then it's run through facial analysis models that are doing this kind of affective stuff and so forth. So below each of the image, you have a little caption. Here on the left image, there's an algorithm trying to identify her gender. And it's saying that she is 57% female and 42.85% male. Okay. The right-hand side is trying to analyze her emotions. It's saying that she is 73% sad and 17% disgusted. And when you look at the details of this, again, we start to see the kind of politics built into the system, or the assumptions built into the system. On one hand, we see an assumption about gender. If Hito is 57% female, then who is 100% female? Is Barbie 100% female? Is Angela Merkel 100% female? Is Grace Jones 100% female? And who gets to decide what that is? And moreover, who decided that gender is binary here, that those are the only categories of gender that exist? And again, what we're seeing, my point is that we're seeing political decisions that are encoded into technical systems under the guise of a kind of science or something like that. And we see more of that, the more we find this kind of thing going on everywhere in training sets.
Well, this has been part of the fun of doing this project together, because we basically sit down and look at hundreds and hundreds and hundreds of training sets. And I wanted to share this one with you, just so you can see how far this goes. This is the UTK face data set, which has over 20,000 images of people, all labeled for age, gender, and ethnicity. And it should be no surprise to you now that, of course, gender is coded as 0 for male, 1 for female, nothing else exists. That's all you can be. But have a look at the racial category, because this is where you will find something incredibly disturbing, which is that race is categorized into just 5 groups. You are either white, black, Asian, Indian, or other. Okay, yeah, other, my favorite. So obviously, this is a laughably narrow set of classifications. But I think there's an even more problematic assumption here. This idea that you can even ascertain somebody's race by simply looking at a photo of them. I mean, we've had science for decades that has completely thrown out this idea of biologically determined race, and yet it's coming back again like a zombie into precisely all of the systems that are training AI. And it's interesting because those same categories have this very profound echo into something called the Book of Life. So the Book of Life was a system that was used in apartheid South Africa in the 1970s. Basically, citizens had to carry a passbook that would classify you into one of 4 groups. You were white, black, Indian, or colored. And depending on which group you were classified in by the state, it would determine where your kids could go to school. It would determine what job you could do. It would determine where you could live. And actually, sometimes people were randomly allocated from one to the other group, not really given much of a reason, and having to completely profoundly change their lives. And of course, there was a technical back end that supported the Book of Life. This was IBM's sort of early database technology that made this possible for apartheid South Africa. So when I see these sorts of categorizations of race, it takes me right back to those sorts of examples that for me as an academic, we get raised on, but I think in some ways in computer science labs, they haven't seen the harm that those kinds of categories can do. So far, we've just basically shown you some pretty modest scale training sets. They have narrow ranges of emotions or binary gender classifications, but now we're going to scale up to something much more complicated, when you really start to create thousands and thousands of complex and very fine-grained classificatory schema, which of course brings us back to ImageNet.
Yeah. So as Kate mentioned earlier, ImageNet was first published in 2009 when a group of computer vision researchers from Stanford and Princeton came together to create what they called a map of the entire world of objects. So this was a training set whose ambition was massive, and it was intricate. They wanted to really make a collection of images for every object that existed in the world. They came up with a training set that consists of over 14 million images that are organized into more than 20,000 categories. And it's vast and huge and intricate. There are 1,478 pictures of strawberries, 932 pictures of strawberry ice cream, 604 pictures of strawberry daiquiris. There are classes for apples, apple butter, apple carts, apple fritters, apple dumplings, apple jelly, apple juice, apple pie, apple turnovers, apple sauce, crab apples, Adam's apples, candied apples, dessert apples, May apples, and it goes on and on and on and on and on. And if the project of ImageNet was to map out the entire world of objects, the question that we want to ask here is, what counts as an object? And this might seem like a really naive question, but I think that if you start asking this question, it actually gets really complicated really quickly and really messy really quickly. And the reason for that is that creating categories is kind of like sorcery. To create a category is to summon some kind of new being into existence. And here's what I mean by that. The world out there is an infinitely complicated place. And to make sense of it, we have to slice that world into different concepts or categories so that we can make sense of it. The point is, however, that those categories, those are human constructs. They don't exist out in the world. They exist because we make them. And while it might seem at first blush that a term like apple might not be particularly controversial, things get much, much messier when we start making up categories for people. Now, here's an example of a neural network trained on ImageNet looking at a scene from the Zuckerberg hearings in DC. And in this image, we see some things being described. We see a chair, some furniture. We see a black tie. But we also see people being identified. We see somebody described as a legislator, somebody as a leader, somebody as a worker. And The noun worker is not a noun in the same way that the noun apple is a noun. At some point when we're talking about people, this idea, this range between a description and a judgment starts to get very, very fuzzy. Why is one person a legislator and another one is a worker? Why is somebody a leader and somebody else is simply called a person? Well, ImageNet contains about 1.2 million pictures of people. And those pictures of people are organized into almost 3,000 categories. And let's take a look at some of these categories. One category is an acquaintance or a friend, a person with whom you are acquainted. This is an odd category simply because one would imagine that the set of all acquaintances in humans is basically the set of all humans, right? Okay, okay, fine, weird category. Debtor, a person who owes a creditor. I can't imagine how there could be a relationship between a photograph of somebody and their bank account, but here you have it. It is there. Here we have a category, bad person, a person who does harm to others. It's this section of the training set is mostly, again, populated with mugshots. But I question how the people that put this training set, how did you know if somebody's arrested and they have a mugshot, how do you know that they're a bad person, right? I mean, that one doesn't necessarily follow from the other. Hypocrite, dissembler, phony, pretender. These are getting very judgy. Frateur, okay. If you don't know what this is, look it up, kids. It's a very racy. Failure, loser. This is just straight up mean right here. Jezebel, drug addict, junkie. So when we look at these kind of categories, the very existence of the category is a judgment. It's not a description. And some of these judgments are really, really suspect.
So how about we take you down a level to actually start to see some individual images? Now, just remember, all of the images that we're showing you have been scraped from the internet, from people's pages. They have no idea that they've been put in sets like this, and certainly gave no consent to do so. And obviously, these images no longer exist, but what I thought we might do is play a bit of a guessing game. I'm going to show you an image. Try and guess what you think the label will be. All right. Can you see this one?
Yeah. Whoa.
Whoa, it just did something else. Sharecropper.
Wait, there.
Can you see that? We got some weird thing.
There's some bullshit on there.
If you guys could, yeah, thank you. You're going to ruin our game. So this is an image of a sharecropper. Who knew? These guys are close. Snobs. I like that, though. That made sense. This one, maybe not so much. Try this one. What was that?
Drunk.
Drunk? Interesting. Tosser. Try this one. Interesting. Actually, loser. Not very kind at all. Try this one. Yeah, that would make sense. In actual fact, it's mixed blood. Yeah, that was our reaction. And then this one, which is an image of a woman in a sports bra taking a selfie, pretty straightforward. Any clues? What would you call it? Selfie. Yep. Actually, it's slattern. Yeah. And then here's a face you probably know. Yeah, guess what this guy gets labeled as? Anti-Semite. Yeah, very topical right now, actually. Interesting. And in fact, he comes up again in this image where he is labeled, wait for it, Bolshevik.
Well, our joke in the studio is that Barack Obama's in every single category. He's like a nice guy, a tyrant, a dictator. You know, it isn't like every single category.
He is one of the most commonly seen faces in the entire set, so he gets almost every category. And then you have stuff like this, which good luck trying to figure out what that one is. It's toy. So as you can see, there's an incredible type of flattening of meaning that is going on here. Every one of these images has a very rich context. Sometimes it's just a very innocent, prosaic image of everyday life that's getting an extremely harsh judgment applied to it. But more importantly, you're starting to see how this relationship between an image and a label is never straightforward. As much as AI likes to tell you that this is like a solved problem, this is very far from being a solved problem. So as we discovered to our surprise when all of these images disappeared, as we started to give talks about them, we thought, hey, maybe this is a good thing. Maybe it's good that these images with some pretty troubling labels are no longer visible and they're no longer available. But we actually started having different sorts of conversations around some harder questions, like what happens when you lose significant parts of AI's history? How do we track how many other systems have been trained on those images? Because Trevor showed you one, YOLO 9000, but there are countless that have actually used these categories, just lock, stock, and barrel, imported them and used them. We don't know how to trace that. That's a very hard thing to find, particularly when things start disappearing. And then finally, shouldn't we be discussing exactly how these types of classification systems actually work? Again, very hard to do when they just disappear. But we do have some good news today that I'm going to let Trevor share.
I think it's good news. I don't know if it's good news, but basically when we're monitoring ImageNet a lot in the studio in Berlin because we were working with it every day, and at some point we started watching it disappear in real time, started freaking out. I called you, it's like, what's going on? The image is disappearing.
I'm trying to back it up.
But the good news is we were actually able to back up the whole thing, with a very fast turnaround. And so we had this collection, and I thought, you know what we should do? We should actually just build a neural network that's based on the ImageNet people categories. Let's build a model that will allow us to see people and the world through the eyes of the ImageNet people classes. And so I did that and started running it on images of people that work with me in the studio, starting with myself. ImageNet decided...
By the way, Trevor is not a member of the Ku Klux Klan. I just want to make that very clear.
Yeah, in the ImageNet it says I'm in the Ku Klux fucking Klan.
Thanks.
Kate turned out quite well. But I do think that this falls into the category, of a broken clock being correct twice a day.
Oh, thank you, Trevor.
ImageNet is very unkind to Leaf, who actually does all the software development in my studio. And it's just really mean to him. Here it says he's a creep, a weirdo. Sometimes it tells him that he's a homeless person. Sometimes he's a rabbi.
Yeah, I liked it when we fed this system an image of Leaf at a protest in Berlin. Yeah. It said he was an anarchist, and he was much happier with that.
Very happy.
He's like, yeah, I'll take that one.
So I'm also happy to say that here for South by Southwest, we have a working prototype of this that we can make public. We created this web app, and what you can do is you can upload a selfie or send a picture to the site, and you can take a look at how the ImageNet people categories classify you. We don't, of course, keep any of the images. They get deleted after use. But I do want to warn you that if you use this ImageNet roulette application that we created, very regularly returns horribly racist and misogynistic labels, and that I actually don't think that there's anything funny about that. The point of the project is really to show how these kinds of politics propagate through technical systems. Yeah, so try it out, ImageNet-roulette.paglen.com.
So I want to make it really clear that it's not just ImageNet that has these issues. We have seen them repeat over and over again. It's just that ImageNet is an incredibly important benchmark training set, and so it really deserves to have a lot of attention in terms of how these things get created. And again, because the competitions around ImageNet haven't really looked that much at the people categories, they've kind of just disappeared from view, but they haven't disappeared from AI production systems. So they were being used for a long time. So in short, the kinds of epistemological, political, and ethical issues are really cropping up everywhere as we keep looking at hundreds of these sets. So you might now be thinking, what is the resolution of the mystery that we started this talk with? Why did all of these images of people go missing? Well, for researchers like Trevor and I, it's been really strange to see something like this, so core to the representation of AI, basically just delete everything in this person category. And this is why we have to kind of go into what we call our Scully and Mulder mode, where we're like, why did this happen? What's going on? Well, basically, I think we can all make a pretty educated guess. The current focus on the problems of bias and discrimination in AI is basically meaning that categories like this are just too controversial to keep up. Now, that frankly, people in the computer sciences are starting to realize that the social implications of some of these machine vision systems can be quite serious. They are, in fact, starting to clean this up. But there is a deeper mystery here as well, and it's a much harder one for us to solve, which is, can you ever be rid of problems like this? Will classifying humans always do some kind of harm? Speaking from a personal perspective, I actually think that's the biggest question that we have to answer if we intend to keep using these kinds of tools. So Trevor and I are about to publish a journal article and then later a book that will go further into these issues. But we thought we might just end by sharing with you some of the things that we've learned in this ongoing project so far. And I think the first thing really is that images function very differently in AI than you might imagine. They're doing a profound type of cultural work. So you might think of the images that you put up on Flickr long ago as like static memories or private moments that you shared with a few friends. You probably didn't realize that they've now been enlisted in a very different project. They are shaping the way technical systems see, interpret, and predict what's happening in the world, often in these really unexpected ways. The second thing we've learned is I think doing this type of work is actually really useful. It's really great to be able to open the hood on a training data system and see how it actually works, see what lies beneath the supposedly neutral computer logic. So by looking into this visual underworld, we can start to pull apart these claims that artificial intelligence is somehow objective or universal. Because of course, nothing could be further from the truth. Doing this type of AI forensics has basically taught Trevor and I so much about how these systems work and where they can go wrong. Which is why I think it's really concerning to us that the majority of training sets in the world are actually proprietary. You're not going to see them. They're locked away in the halls of Facebook and Amazon, and nobody is able to audit them, research them, or understand how they work at all. So finally, perhaps the most important lesson has been that classification is always a deeply political act. Assigning identities to people, judging their characters, is this profound moment of exerting power over them. So it really matters who gets to do classification. Now, civil rights history reminds us that there's a real strength in being able to say, I am a man, or I am a woman, or I am neither a man nor a woman, I am a person. Because deciding ultimately what images mean is the root of power. Every social struggle has been a struggle for meaning as much as a struggle over rights, because the two are ultimately inseparable. Struggles for self-representation are exactly that, struggles to define the meaning of your own image. And this is why we think it's important to understand how AI works and how it classifies us. It's also why we think that we should be concerned when parts of AI's history just vanishes, because it makes it so much harder for us to see how these training sets work, and particularly when they've been the basis for so many other systems that are in production. And finally, it might mean that we forget these important lessons, which means that we will be doomed to repeat them. Thanks. Thank you so much. We can go to questions now. I'm sure you've got a few. We're going to stick around for a bit. There are mics up the back if you prefer the spoken version. It's always nice. There's also another version that can crop up on screen over there if you have questions. Oh yeah, we got a stack already. This is great.
Here you go.
Trevor, what do you feel like? Do you want to talk about China?
Yeah, we can talk about China. Do you want to talk about China?
Let's talk about China.
Okay, let's talk about China. China is developing this thing called...
You should read the question first.
Okay,
yeah.
the question is, what are your thoughts on the social credit system in China? Is it or will it be using image recognition technologies to create another book of life? Yes, and much more, right? For those of you that are not familiar with it, the Chinese social credit system is a state effort to track all kinds of behaviors and metadata points of people's activities, whether basically what people do in their everyday lives, and are they engaging in activities that the state approves of or doesn't approve of. And you have basically a kind of a citizenship score that can go up or down. If it goes up, you can get things like discounted movie tickets, but you also become eligible for access to better schools. It becomes easier to travel. And conversely, if your score goes down, it makes it more difficult to travel. You don't have access to the same range of services that you otherwise would have. And so we've talked about this a lot, and we think, I'll speak for myself, I think this is a bad thing, but I also think that it's a mistake for us here to look at that system and say, oh, well, look at what the Chinese are doing. That's so horrible. It's a dictatorship. We would never do that here, because in some ways we see exactly those similar kinds of parallels going on here. It just takes a different shape.
Yeah,
it's
exactly.
What would be the social credit score with American characteristics be?
Yeah, I think we've seen a bit of that. The other thing that's really interesting that nobody talks about is that China passed actually quite a strong set of privacy guidelines, a little bit like the GDPR. And it's really interesting that people's theory around this is that they're actually training Chinese companies about how to meet particular types of international standards. So what that means is that in weird ways, there's actually better privacy protection in China than you have in the US. And that means that for all of this focus on, China has this terrible system, a system and a set of systems are being built all of the time in the US right now with no federal privacy law. We don't have one. Now, there's a lot of action right now, people trying to get one passed, and who knows, maybe we'll get there. But at the moment, there's this sort of tendency to think that things are so much worse everywhere else, and unfortunately, that's just not the case. Mm-hmm. We've got some great questions here, too, that are coming up. Who initially classified all these images? This is a great question. Trevor.
Again, you've actually done a little bit more work on this than I have, but I've done some work on it, which in terms of ImageNet, and this is general of the industry, is that you use online piecemeal laborers to do it. So you use a platform like Amazon Turk, for example. Typically what you'll do is you'll scrape the internet for images based on keywords, and then you get a bunch of unfiltered images, tons and tons of images. And then what you have to do is you create your taxonomy, so you say what categories you want to organize things into, and then you create an interface for Amazon Turk workers to be able to attach tags to specific kinds of images, and you validate that a couple times through other people, and if you get a consensus of like 2 out of 3 people that say this label applies to this image, then you kind of deem that good. So that's generally how it's done, and the point is that there is a whole substrate of really precarious labor practices that go into this, and this is something that you've certainly written about with your Anatomy of AI paper recently, too.
Yeah, I mean, there's actually a lot of really great scholarship if you're interested in really getting deep on this. There's a new book that's about to come out by Mary Gray and Sid Suri called Ghost Work. And it looks at people who work on platforms like Amazon Mechanical Turk, Crowdflower, there's a few of them now. But essentially, they're given tasks. And if the task is, how many of these pictures are apples, that could be what's called, just a straightforward hit on Mechanical Turk. But this sort of new category of labor is something that is actually a huge area of research that we've been talking a lot about. Mm-hmm. What do you like next? These are good ones, guys.
Can I ask a question?
Yeah, please. Hard to see. Oh, fantastic. Yes.
Yeah.
A live person. Wonderful.
Yeah. It's too long for a slide.
Yeah, totally.
I don't know if you read a paper, I think came in 2018, a journal paper from Stanford, and it was about classifying gay, so finding people's sexuality based on a single image. So that paper got a fierce rebuttal not only by the LGBT community, but also by researchers in other areas. So the question is, do you stop this task, this classification task, or do you include a broader research community to solve these classification problems? What's the right answer from your point of view?
This is a fantastic question and something that we spend a lot of time thinking about and talking to researchers about. The paper that you mentioned, which was by Kaczynski and Wang, again, a sort of Stanford paper, was problematic for many reasons. Not only did it claim that it could detect people's sexuality based on what they refused to say which dating site they'd scraped it from, but it looks pretty much like it was OkCupid. And they're claiming that these are biological markers of your sexual preference, as opposed to the fact that if you wear your hair in a certain way, or if you have particular types of style in terms of what you're wearing, or if you're a woman and you have short hair, you're much more likely to be classified as gay rather than straight. Like, these are cultural representations. These are not biological representations. So they really didn't control for that, so there's huge scientific problems with that from the beginning. The second problem with that paper is that they claimed, using, again, a disputed theory about neonatal hormone theory, that you were exposed to hormones, as you were gestating, that made you a particular way and that shaped your sexuality. Again, profoundly disputed by the sciences, and this weird theory sort of returning again in this sort of type of machine learning universe. So papers like that concern me for a bunch of reasons, but I would say, first of all, they have massive problems with scientific validity, and then secondly, they have massive problems with the ethical formulation of why they think this is a good idea. So there's like a little section at the end of the paper that says, oh, this might have some ethical problems, but we did it because other people could do it, so people should know. And now, that is a huge problem when homosexuality is actually banned in, I think it's now almost 70 countries, some of which carry the death penalty. Like, this is just a radically inappropriate tool to just release into the wild. So I actually think the whole industry needs to step up and start thinking about responsibility for what is made and accountability for when those tools go wrong. Because at the moment, it's just like, oh, we tested it, it kind of worked, chuck it out there, we saw some correlations. I just don't think that's either scientifically or ethically appropriate. Over to you, Trevor. Pick a question.
Pick a question.
Slido has some good ones.
Is it better to expand the categories or flood the system with more images in counter categories? I think that's a really good question here, and I think this gets down to this very fundamental, basically kind of an epistemological / metaphysical question, which is categorization always, particularly when it comes to humans, going to create a kind of violence, right? And I think the answer to that is yes, for the most part. Like, doesn't mean that you necessarily are not going to need to use them. But I guess we can shift that question around a little bit. And this is, of course, something that we were talking about in the talk, which is we can reframe that question to be like, to make it be about who gets to define what those categories are and what the meaning of those categories is.
Yeah.
And we've seen this over and over again in many different kinds of social struggles. So, for example, in queer liberation struggles, we see early attempts to redefine being gay from being a deviant medical condition to, something that's just a perfectly reasonable thing. We can see, and again, we see that that's a history of feminism, there's a history of civil rights, so there's basically every kind of social struggle has been an attempt to reinscribe the meaning of one's identity in relation to the broader society. And I think that dynamic is different in technical systems, because if you have like a technical system like a Google or like a Facebook or what have you, you're seeing those top-down classifications those are rigid classifications. In other words, there's not feedback loops where, Google doesn't say, oh, I've tagged you as a, whatever, some horrible thing you said. No, I'm not actually that, I'm actually this. That just isn't how the systems work. And so there is that a kind of system of top-down judgment happening continually and happening invisibly, right? And so you don't see it happening, you don't know what the consequences of those judgments are.
Exactly.
And so I think it's a multifaceted problem there.
And it sort of relates to this other big problem that you've been seeing happen a lot lately, which is, here's a broken system. Let's just get more representative data, and then everything's going to be okay. So you probably saw a really important paper by Joy Buolamwini and Timnit Gebru that said, hey, facial recognition systems actually work great for white dudes, really bad for women of color. And that was a really important finding, but the response has always been, we'll just get lots and lots more images of people of color and women, and then we can use facial recognition fairly. Well, actually no, because facial recognition is deployed in ways that are completely and totally uneven around over-surveilling the same low-income neighborhoods and neighborhoods of color. So these are not tools that are used in fair or equitable ways. So just making sure that they have parity, this idea of technical parity, is standing in for fairness. And so we've got a real problem here around, do you just tweak these tools to make them better, or do you ask these more fundamental questions about where they should be used, where they shouldn't be used, and where they might actually be creating harms, no matter how technically perfect or representative they are?
Maybe we'll just, if there's one more audience question.
Yeah, audience
like
questions
that,
are fun.
do that.
Does anybody want to be brave and run up to a mic?
Okay.
You've been such a great audience. Go on, there we go.
If you worked at one of these big tech companies that has one of these proprietary data sets, what would you do to address the problems that you're bringing up here? What would you do first? You've mentioned a lot of different things.
Yeah, I mean, there's a lot of things. I don't think that, I mean, one of the responses has been, and scholars have published this, just release all of the images, make them open source, make people see them. I don't think that gets to these deeper questions that Trevor and I are interested in around what happens when you just classify people. I think there's a lot that companies can do, though, in terms of thinking about some of these very simple problems which shouldn't be there, like gender being binary. I mean, this is something that is bafflingly out of date. And seems to be just like an obvious thing that could be changed. And again, you'd have to ask, Facebook or Apple. I would be surprised if they were still using those categories. In fact, Facebook expanded its categories for self-identification to, I think, over around 70 categories. And you might say, hey, that's a great story. Facebook is thinking about multiple forms of self-identification. But by even creating those labels, you can see that what they're actually doing is arming yet another type of extremely highly targeted AI system, rather than saying, leaving identification off, or having a text box so you can write in whatever you want. The fact that you have those categories is really about them training a back-end AI system. And a lot of people still don't understand that that's how Facebook works. They think it's a messaging platform or it's a place to share photos. It is one of the biggest AI engines that we have, and those choices around tagging are really about making that system much better and much more precise in terms of how it can understand specific individuals.
What about, it's not only companies, though, too. When we're looking at a lot of this research, it's really hybrids between, we see very blurry borders between, for example, a Stanford and a Google, or between a Stanford and a Facebook, or what have you. I mean, and so a lot of the training set and a lot of researchers is happening in universities, and this is something that you've looked at a lot. I studied social science for a while, and if I wanted to even interview somebody, I had to go in front of an institutional review board, and I had to say, I want to talk to these kind of people, and this is how I'm going to protect their data, and it's going to go in a safe, and you have to have these elaborate procedures, and they would judge you and check on you, and and say whether what you were doing was ethical or not. You had to get approval for that, and to a certain extent, this history of AI has been couched in computer science, but I think what's very obvious now is that we are very solidly in a world where anthropology has something to say, geography, so, the literature, semiotics, I mean, we are in a lot of these questions, we're deep in humanities territory in terms of how questions are being articulated, and deep in social science territory in terms of relationship to human subjects and working with people. how do you, so you have a background in many different parts of this. How do you imagine a new frameworks for like best research practices with some of these things?
Yeah, I mean, the way that, this is actually one of the reasons we created the AI Now Institute, was that we realized that there weren't really interdisciplinary spaces for critically engaging with AI. So we really do need people coming from the humanities, the social sciences, and the technical sciences working together on these sorts of issues. And actually, if you go back, AI was always an interdiscipline. You'd have people like Margaret Mead sitting on stage with people like Claude Shannon. I mean, it was very much trying to get these different fields to talk to each other. But we sort of lost that with 30 years of it becoming narrower and becoming more and more a technical discipline, which is exactly why we saw things like human subjects review drop out of the picture, because people are like, oh, it's just math. It's just straight up math. There's no reason that you should be worried here. Well, actually, what we're starting to see is that when you apply that to social institutions, there's a lot of problems that can appear. But these are not the problems that you'll be trained to think about in computer science and engineering. So there are changes that are being made in those fields. You're starting to see ethics courses get introduced. That's fine. But I actually don't think computer science should be the central locus for this anymore. Yeah. I think it's too important. If you're going to put these systems in criminal justice, in education, in HR, everywhere you like, in healthcare, we have to have more experts in the room thinking about how they work and how they can go wrong. And sadly, on that note, we are at time. Thank you so much.
Thank you all so much for coming.
It was a pleasure. Thank you. Thanks so much.